going to serve as a tutorial to set up your picoscope or your oscilloscope to test for a certain kind of sensor. I will run through how to identify what kind of sensor we're testing, where to locate it, back probe it, etc., how to set up the oscilloscope hardware, software, plug it in, turn it on, and run your tests. So that's what we're going to be doing today. In the case of this Ford Fusion, we have a tone ring with a variable reluctance wheel speed sensor, which that means we're going to be inducing a signal voltage through the wires, and the vehicle has a bug where two of these teeth, so to speak, are ground off on the tone ring. So we have a bugged tone ring, and I want to see how that affects my waveforms. A normal waveform, we should see an AC voltage signal up and down with a certain amplitude and frequency depending on how fast you spin the wheel. And what I'm expecting to see during my test is the waveform to cut out or to not represent our example waveform every few teeth or so. So that's expected normal operation versus expected bug operation. And then we have to be able to set up on our vehicle in order to accomplish this test. So what I've done before I began setting up the oscilloscope or plugging anything in is I, of course, RTFM, I read the literature. So I went to Ford PTS, I navigated to the wiring, I went to Vehicle Dynamic Systems, and I found the left rear wheel speed sensor. I verified that it's a variable reluctance sensor with a ground and a signal voltage wire. And then after I verified that, I checked for my connector face. I verified that the connector face I'm seeing in literature matched what I'm doing in person. And I also made sure that I back probed properly with my wires to ground and to our signal voltage wire, in this case, pin 1 and pin 3. So once I verified all of those steps, I booted up my picoscope program, and I was prompted with a quick setup guide or a testing guide, which I will gladly have helped me set up here. So in this case, I'm selecting wheel speed sensor because that's what I'm testing. And in this case, it is the inductive type. So I go ahead and select inductive, guide and settings file. So this can be helpful for students to help set up their tests independently just by working through the directions provided, nice visuals on how to set up the hardware and software. So I've read through all this, I'm ready to go. I can go ahead and minimize the guidance, and I can set up our hardware. So in this case, we actually have the picoscope computer. We have our ports with our different wirings. In this case, I just like port B just because the color looks nice on the graph to me. After that, I am going to make sure that I am plugged in everywhere. That means power is turned on. That means that all of my communication wires are connected. So laptop to Pico, Pico to vehicle, and then I need to turn the vehicle on to make sure that I run through this test properly. And I knew to do that because I read literature and it stated that I need to turn the vehicle on before I begin my test. So I located the connector for the wheel speed sensor, which in this case is just right in the left rear of the cab of the automobile. And I went ahead and I back probed into wire 1 and wire 3. This is our ground wire, this is our signal voltage wire. I make sure that I have good connections. I make sure that I am getting readings from these wires in the first place and not just hoping that the tool is functioning. So I'm verifying function while I'm setting up this back probe here. After I've verified I'm fully back probed, everything is plugged in and turned on, I'm going to then tell the computer and the software that I want channel B to be turned on. It needs to be AC voltage because that's what is being induced in the system. And then it's turned on. Let's go to about plus minus a singular volt. And then we're gonna select this top left option to begin the test. So from here, we should be sitting right around 0 volts because nothing is happening in the system. There's no physical movement to induce a voltage. I'm going to then start to spin the wheel slowly, and you will see an overall waveform begin to appear. With a little bit of a slow rotation in the tire, you might not actually see the tone ring show up because your waveforms are already so erratic. So if I spin the wheel a little bit faster, we'll start to see consistent waveforms, and then we will have a complete drop or freezing of those AC waves. And that's an indicator directly that our voltage is not being induced as we need it to be to get a proper signal.
Good.
That's it.
Cut.